moment.
All right.
All right, go ahead.
All right, my presentation was on distributed lock manager. What is a distributed lock manager and why is it needed? In general, it came from because the internet was expanding and the computers becoming cheaper and cheaper, and basically people communicate with each other, and there has to be a way to asynchronously share file without any problems. So that's why distributed lock manager came in. You have clusters, which are basically computers which connected together in sets. And each of these computers represent like a node. It doesn't have to be a computer. It could be anything like database or anything like. And so what distributed lock manager allows is a concurrent application that run on different machines in the cluster, synchronized access to shared resources. What it means is that several people can connect and use the same exact file and change the same exact file, but they'll have to the distributed lock manager allows them to do it in a way without breaking the whole or corrupting the whole file. So the way it's done is with queues, and later on I'll explain what queues are. So here we are. The basic rules for distributed lock manager to work correctly is the resource must always be referred to by an agreed upon name, meaning that whatever that file or whatever, every single computer in a cluster has to refer to the same file or whatever by defined name. That way, one computer doesn't call it one thing or the other. Otherwise, if you call it by different names, then 3 computers connect to the same exact file, change it, and it will just corrupt the file. Don't know which one to supposed to update. Access to the resource is always accomplished by queuing lock requests. Basically, it's just simple. If I come in first, I make a request, I want to have this file, and I want to edit this part of it. It puts me in a queue. If nobody else connects to that file and nobody else wants that part of the file or part of the table, then I get a permission to use it, edit it, and whatever not. And there is a certain time. And last, all lock requests that are placed in a wait queue must wait for access to the resource. Basically, if you're placed in a queue, there is no way for you to jump ahead, unless there is certain, of course, exceptions. But normally you cannot jump ahead, and you just wait till it's your turn. Granularity of the lock. This is just basically says what level of lock you're placing on. Granularity, just like it says, like lock can be basically on a full system, which is called coarse grain lock, or like a full file, or you can have fine grain lock, which is just a specific. It could be just a row, it could be just a small file, or something like that. The whole difference is this: fine grain locking, you maximize the parallelism. Basically, if you have one file and one person editing in one line while the other person editing some other part of that same file, more people can work on the same exact file. Versus if it's coarse grain lock, only one person can work on that file if he locks the whole file. But the difference is coarse grain lock minimize the overhead. So there is a plus and minuses to each one of them. Okay, next is I'm gonna first define you the basic general concept of lock mode. Each system defines their own kind of like for example, later on I'll show Oracle. It's the same exact lock mode, but they use different names. It could be X, it could be E, and as explained. So first is NL, which stands for null. Null is basically no access to the resource, interest in resource. Basically, like, you're not really placing anything. It's not locked. Anybody can use it, but you show like, hey, I might be using it sometime. I'm not sure yet. Next one is concurrent read. As it sounds, it basically you place a lock on it, but anybody can still use it. Anybody can edit it. And as somebody else editing at the same time, you can read it. It is called unprotected, basically. Concurrent write, same thing. It's unprotected. And write access to the resource is allowed. And share the resource write. Anybody who can write can share it. But you cannot read it, though. So I think you can, sorry. Then protected read is now known officially as a share lock, and read access to the resource and sharing resource readers. No writers allowed, because if somebody is reading and somebody editing at the same time, then it's going to be really confusing. And you complete something reading, but somebody will change it and your information already different. So protect reading is no writing is allowed. Protect writing is also known as update lock, write access to the resource, and share resource CR mode. No writers allowed. So this is only one writer is allowed at that point. And last is exclusive lock, means writing access to the resource and no sharing of the resource, also known as exclusive lock. So that's the highest. As you can see on the side, how severe the locking is. The highest being with exclusive, the lowest being the null. All right, so this is the lock mode, and this is shows you compatibility of the lock. It's very important to know, because if you can understand this, you'll be able to set up your distributed lock, whatever application, whatever you're making, without any problem. So as you can see, null can use it with anybody. Any other modes can connect to it easily. There's not a problem. With the next one is the concurrent read. Same thing, almost everything besides exclusive. Exclusive will always have predominant. If somebody has exclusive lock on the system or on a file, nobody else can access it. That's all it is. If you have concurrent writing, then almost everything up to the lowest level can access. But you cannot do protected ones, because those are more strict, again, as I explained. And this again repeats. So protected read and exclusive, whatever. So, all right, the way I'm going to show you example, I use the Oracle distributed distributing lock API to show how it works. So first, remember, as I explained, even though it is Oracle one, they still have the same exact concept, and you can associate them with original one, but they call them differently. So instead of like null is null, but concurrent read could be assassin this, and it's very similar. So just for your understanding, there is also HP one. HP uses even more complicated ones. There is so many more than this, but at the end of the day, you can correlate them to this, the basic one. All right, so first, lock resource. Resource basically means any file, database, anything. So first time when somebody lock manager requests, somebody basically makes a request to lock that resource, lock manager will create a lock resource for that specific resource in response to the request. And this is how resource looks. You have resource name, which is string of no more than 64 characters. You have log block value, and you have a set of lock queues. The lock queues, I'll explain later on what it is. Just there's 3, but this is 3 is in general. In Oracle, you only have 2. You have grant queue and you have convert queues. You don't have the wait queues. So not to confuse, because later on you're not going to see these 2 options there, but it's very similar. It's just the 2 of them combined into one basically for them. So in queue, as we know, it's first in, first out. Granted queue, basically grant lock request tracked. All the grant locks, basically whatever lock is already has been granted, you're given permission to, will be stored in here, like basically it's granted. And converted queue, which means like, converted queue means like you try to make a request, you try to get the permission on that lock on that specific section of file, but there's a complication and somebody else already using it. So you cannot use it. So you are put into wait lock request, basically track. But it's considered in Oracle just convert queue. It's a one thing for them. So now I'm going to give you an example of how it will work if you try to make a lock, basically, based on their API. They use asynchronous trap, basically interrupts. You have acquisition, tells the request that the request owns the lock. Basically, when you start something, it will tell like, hey, somebody else already owns this. And it's going to call acquisition. And then blocking acquisition, AST, basically. Tells the process that current on lock on the resource is incompatible mode. That's for the converted queues, basically. That's what it's for. It will tell that, hey, you tried to get, but it's not compatible. So you cannot use it. Now, persistent resources. The persistent resources is important to know because this will help you. If, let's say, you had several locks on a system, and all those locks for some reason fail or disconnected, the user disconnected or something, and you don't know what he changed, what he didn't change. And persistent resource allows you to revert to the earlier state. Not all the system implement persistent resource, but the newer ones do it. It basically says that it maintains a particular state in case of process or group hold lock and have died abnormally. That's what it does. You have a lock value block. That's where the resource basically says what kind of state you're in right now. It's 16-byte, and it communicates the log between processes. Information to protect resource, don't recover. That's what basically does, as I explained. So here it is. Here you have log block value, you have granted queue, you have converted queue. In granted queue will tell you what kind of locks is already allowed. Converted queue is basically what's going to be next. So we have process 1 over here, and we have process 2. So, for example, process 2 wants to get exclusive lock on lock 2. Even though it already has shared lock, if you want to get exclusive lock, it starts a new one. It goes back in the queue and will ask for permission. So at this point, you're gonna get a permission from if nobody else holding it to use the exclusive lock. So from converted queue, process 2 will be transferred, and you're gonna have an exclusive lock for process 2 on lock 2, and that's what it is. This is all dumbed down version. Obviously, it's a lot more complicated if you write the program for it or something, but this is what it is. If you a quick process how you run down to. This is a general example of how you get a new lock, and it's expressed in all the 3 queues. You start new lock request. If it's granted, you have granted queue. If it's blocked, you have a wait queue. But let's say like you have new request, it's not granted, you can convert it. Convert it basically, you try to check, okay, if this is available, okay, no, how can I go around it to make sure I can get it in another way to the same system, basically. So if it lets you, you get granted queue. If it doesn't, you go back and converted queue. And normally you'd go back into waiting queue if you cannot get converted. Okay, this is the important part is distributed deadlock detection. Basically, if you can see with distributed lock manager, you will have obviously a problem. Like let's say several on one system is pretty simple to implement. Basically, like, yeah, this file active, okay, you cannot use it. But when you have hundreds of computers connected to the same place and they try to use the same resource, you can have problems, and you can have deadlocks. That's what they call them. So normally a process state, you have a running state or have blocked. A running state is basically a process continue to run and everything is fine. A block state, a process waiting to acquire some resource. So this is 2 different states you have. Now, the most common way that is used and determine if there's a deadlock is called wait for graph. You see what you're waiting for. Easy to see a state of the system. A system is deadlocked if and only if there is this direct cycle or not in the wait for graph. That's what WF stands for. So basically, there's a circle. It says, I'm waiting on this, A waiting on B, but V is waiting on A to use some other part of the same file. As you can see over here, P11, P21, P32, and P33. Let's say P32 is waiting on P33, and P11 waiting on P21, and P11, P32, and none of them can continue because they're all waiting on each other, kind of. So you get a deadlock over here going on. All right. So there's the 3 ways to handle deadlock. Deadlock handling basically. There's a prevention, deadlock avoidance, and deadlock detection. So as we can see here, deadlock prevention. Acquire all the needed resources simultaneously before executing. Basically, what it says is that whatever you want to use, let's say I want to use some file. Before I'll execute anything, I will wait till all the part of that file are available and anything related to it is available. So basically, everything has to be controlled by you. Only then you will deadlock prevention will work for you. Basically, it also preempt another process that is holding the needed resources. It can, but you can wait. Preempt means like somebody else is using it, you just cut them off and you say, I'm going to use it from now on, it is inefficient and impractical, so it's not really used. Next one is deadlock avoidance. Resources is granted to process if the resulting global system state is safe. So again, similar thing. If it checks for all the global state, if everything is nothing is in deadlock and the system running smoothly, then you can then you can determine if there is anything going on. Like global state includes all the processes and the resources of the distributed system, which also impractical in distributed system because there's no way you can take all the resources. That's not the whole point of distributed lock manager, to make sure share the resources. That's the whole point. And last one that everybody uses, deadlock detection. which makes sense. Deadlock already happened, or is there no deadlock? Requires examination of the status of process resources interaction for persistence of cycle. Wait, as I explained already, if there's no cycle, then you don't have a deadlock. If there's a cycle, then you have a deadlock. And this is the best approach. There are several ways that it's implemented. Yeah, so detection of existing deadlock, maintain of the WFG, which is wait for graph. Basically, the goal is to maintain in every system or every node, which is computer, you maintain the wait for graph. That way you know, like, hey, every nodes around me are running smoothly. There is no deadlock detect. Everything is fine. So you search for the wait for graph for presence of cycle or nodes. That's a resolution of detected deadlock. The way you resolve it, you have to make sure there is no undetected or false deadlocks and roll back deadlock process. So the way you resolve it, basically, you make sure there is no undetected deadlocks. Means like, oh, is there a deadlock? And if you miss something, there's going to be a problem, obviously. And there's a false deadlock, meaning that you think it's a deadlock, but it's not really a deadlock. And the way they solve, basically, let's say there's a deadlock, they just roll back the system to previous queue. Whatever happened before, they just like reward and undo whatever the previous changes. Now, there's 4 general approaches to algorithms for deadlock detection. I will just explain you the approaches. I'm not going to actually say what the algorithms are because there's many. And there's a paper like 74 pages explaining like 4 different algorithms because there is different. There could be 1, there could be 2-step ones. It's a lot more complicated. I didn't spend enough time, I guess. First one is patch pushing, then there's edge chasing, diffusion computation, and global state detection. Patch pushing is a very simple, straightforward one. You just maintain the global wait for graph, build a wait for graph for each side. So basically, every node next to you, you first build around you, you send your to the next node next to you. They examine it, they check, and they update it. They send it to the next person, and they send it to you as well. You update yours. So everybody in a cluster update their system, and at the end, they all know what is the global state of the whole system. So, and then that's what basically you have. Local structure updated, update, wait for graph pass to another side, and complete picture of global state, detect deadlocks. If that's a very simple approach. This is one algorithm. Next one is edge chasing. The presence of a probes along the edge of the graph. It's very similar. You do the same thing. You have a small message which you send to your neighbors, and they check. They run a small algorithm. They see what's going on in their system. If there is no problem, they will respond to you. If there is a problem, sorry, they will not. This right here, executing process discarded. The message continues. If the system is executing something already, it will just discard it. Sorry. And if the system is blocked, like there is something going on, it will process the actual message along the outgoing edges. So if there is execution going already, it will not do anything with it. But if there is block and something else, it will have to execute because it wants to know the next state of the system, basically. Next one is diffusion computation. Oh, this was a little bit more confusing one. They use echo algorithm to detect deadlocks. Echo algorithm is similar to, as earlier explained, they similarly send a small message kind of along the neighbors, but it works a little bit different. As you can read here, receive a first message, it forwards to the all other neighbors. When it gets tokens from all the neighbor, it really replies back and how many processes are decided. Basically, how many processes are working and how many are waiting, how many need to be run, all the system, all the information you basically get from it. And after you get information, you can determine if there's deadlock or if everything runs smoothly. And that last one is a global state detection. And again, this is just basically exactly as it sounds. You find out what is the whole exact system of all the, basically, what is the whole system. You determine what is the whole situation of all the nodes in your system, basically. And the way it does, it takes a snapshot, basically, like, that each new application or new distributed lock manager, whoever set it up, whatever they do, try to follow the lock manager and basically get approved by the lock manager. So that's the whole. There are different. There is a Red Hat, there's Chubby, there was a, and I just choose Chubby and Zookeeper and I compare them, and straightforward. They're very similar too. And Chubby was a Google service distributed conscious packs. Basically, distributed conscious means like you want to have different system come together and agree on something. That's what distributed conscious basically means. The whole purpose of Chubby was provide available and reliable system, but it doesn't do high performance or throughput. So, and it works with small files. But it's right now used for many things in Google. It started off with just distributed conscious, but by the time they were done with it, it's ended up performing 4 different major tasks. Coarse grain distributed lock. Coarse grain means like it's very wide lock, as I explained earlier. Basically, like it could be in a whole file. That's what usually is. It also has file system management. Chubby, basically, you can create files and stuff like that. Chubby. It supports election of primary in a set of replicas. Basically, I'll explain later on what is replicas and what is primary. And it uses a name service with Google. This is some of the biggest implementation on it. But I focus obviously on distributed part of it, distributed lock manager. So we mostly cover this, and I'll explain a bit of this because it's integrated with the coarse grain. Okay, so this is the Chubby simple version API. All right, Chubby. Each file and direct is required to have write permission. There's exclusive mods and clients can communicate. Next one is lag delay. It's also, they implement lag delay. It's up to 60 seconds. Basically, if somebody disconnects something or somebody want to use a little bit longer, its maximum could be up to 60 seconds, the lag on the system. That's what it is. All right, so this is me explaining now how the architecture of Chubby is set up and how the lock manager basically works in Chubby. Chubby has cells. It's master and replica, as I mentioned already. It's a big deal. There is an algorithm, Paxos, which determines which of the replica is a master, basically. Yeah, one file and replica exactly the same. The same file replicated 5 times, 10 times, how many you want to, for basically allow more access to it. Or if one file is corrupted, you can use the old one. This is just the typical distributed system, file system, you know. So you have five, like for example, you have 5 system. Paxos algorithm will determine which one is the master file, and then client application communicate with the master session created when it's created, and master lock replica for client read write. So I'm going to explain what it is. So here's a picture. Yeah. Based on the algorithm, it will determine which is the master. The client application will have to communicate with the master if you want to write. Master will pick a file, whatever it is, and return the control to client application. Say it will lock the file and say you can use this file now. Until client application done working with it, basically the master will make sure the client has it. But as long as you go, client will always have to send a message back saying keep this channel alive. I think I explained channel here. Yeah, there you go. There is basically there is a channel. When client and master communicate, there's a special channel set up. And this channel will close the moment client application stops sending keep alive messages to the master. So, and this is how it works. The moment the client done, it will stop sending. And that's it. The master will close this file, updated. Client application is done with it. Next client can communicate. That's how it is. There could be more than one client communicating at the same time. They'll all go through masters as well, and different files will be accessed. Different replicas will be accessed, basically. And another big thing in Chubby is caching. Is basically it allows to reduce road traffic. As with any caching, basically, you don't have to go directly to server every single time. You just use the file and caching. It's like for the read maybe or something, or for the write, but the file has to be up to date. The moment the cache date is altered, the file becomes invalid, and client has to use chubby cells back. So here is example. So we have a chubby cell, we have a local cache. When client first time will start, client will communicate with the master. Master will see that there is one of the file available in cache. So it will set up the file in cache. It will return the control to client and tell them, hey, there is a file located in cache. So client will connect to the local cache over here. It will operate with this file. When the moment, let's say somebody else updated this file, like this old version of client, then client will have to go back and communicate with the master and use one of the chubby cells to finish the rest of the process, basically. So this is how chubby work. This is simple, of course, explanation. It's a lot more complicated than that, but this is the part for the distributed lock manager. Yeah. And next one is Zookeeper. This is one of the most common used ones right now. It was developed by Yahoo, and it can do many things besides lock manager. But one of the things it does, distributed lock managing. It does not require it, but people for some reason tend to use it a lot. So here we have coordinate service for distributed system. That's the whole goal of Zookeeper, was distributed file system and messaging queues. It uses ZAB, Zookeeper Atomic Broadcast Algorithm, to determine, they don't call them master, but they call them leader in this. But same exactly thing basically to Paxos, is the algorithm that is used to determine which of these replicas is going to be the leader or master, whatever you want to call. In Zookeeper, it's called leader. So read, dominate, write. In this is very interesting. Zookeeper, read, dominate, write means that read is more important or higher function than writing function. Read can be done directly with any replicas or leader, while write has to go through the leader. And as you see here, so if client wants to read, it can read any of this replica. It doesn't have to go to leader. It can go just directly communicate with any of this files in this, or whatever it's going to be, tables with this Zookeeper. But if it has to do writing, it will have to go through leader first, and leader will determine the rest of the stuff. Okay, so this is how it works, Zookeeper. Zookeeper works the way it's called sequential files. You have this, so let's say I'm client, I connect to the leader, and I want to alter it, I want to write it. So I'm connecting it to the leader, and leader has this file lock. For example, I want to connect to this file. I will have to create a file underneath it. It's called sequential file. And all the name going to be unique by using sequential file flag. So it's automatically generated, the name, basically. Every time, let's say next person communicate to the same exact file, it will create another file, but it's going to be file 2. So first client connects to file 1, second client file 2. The moment the client is done, this file will be deleted and updated, basically. So this is no longer going to be here then. So, and name is unique, as I say, basically on sequential flag. All right. So now the last part I did is I found stuff that compared Chubby and Zookeeper. As I say, they're very similar. Both can be used to distributed lock service, as we already saw. They are read and write small files. Both of them offer full read and full write, as with many other ones. And there's many similarities, just straightforward, you know, like as you've seen if you keep up, it's just basically very similar stuff, just for the lock manager part of it. Because there is very only differences comes down to is what kind of algorithm they use, not what kind of theories behind them. You know, like they try to do the same thing by using different algorithms, basically. The major difference is this: client must communicate with master for read operations. That's for the Chubby, but for the Zookeeper, you don't need to. Client may directly communicate with any server for read operations. Does not offer primitive operations. Offers many primitive operation. I didn't cover provide 7 events, and this one provides 4. These are just events, basically how the whole procedure of lock manager will work. Chubby has 7 of those events. It could be like start, you know, and there's 7. While there's only 4 of those events. And Chubby manages client cache, and client manages their own cache. There's another difference. And that is all. This is the source I used. There were a lot more, of course, information I could have given, because there was the one for the Linux one called Red Hat. That was pretty interesting one, but it used its own. Like I said, if I was doing different comparison of different algorithms, it would have been more more different. But because the component like manager, at the end, they still cover the same thing. They still have the similar approaches. They just use different algorithms to accomplish the same exact task. And that is all. That is all my Lack manager.
All right, thank you.
No problem.
Any questions? All right, let's move on. Who's next? And please don't forget to evaluate S1.
I can go next.
Okay.
Okay, can everybody see my screen?
Yes.
Okay. I'm Mike Powell, and what I'm going to be talking about is personal file sharing based on enterprise-free, no centralized management solutions. And this is the specific outline. I am going to operationally define. We're also going to look at file sharing solutions in the cloud, file sharing pros and cons, issues with file sharing, and recommendations moving forward. We'll follow it up with any questions that anyone may have. Okay, with regards to operationally defining file sharing, personal file sharing, just the sharing of electronic files over the internet. And when we talk about free enterprise, meaning no centralization for management of services or support. So part of the information that I'm going to render today will be enterprise free, but I'm going to also show you how enterprise-wide also parallels some of the pros and cons with regards to enterprise free as well. So in looking at the different avenues of opportunity for sharing files, there's one provider called MediaFire, which you can share files through email, and through links, or through social networking. You have unlimited downtimes. There's no wait. You have an area for collaboration and areas to which you can store, share up to different types of files, up to 10 gigabits for free. You could share folders. You could also email large files. And I'll give you a perfect example. I can't remember the limit, but I tried to email a draft final project to another group member student in another class, and I exceeded the file limit. So that to me is an issue. Access, being able to view and manage from anywhere over an internet connection. Also being able to mobilely access information from smartphone devices. There are many different plans, from a basic all the way to a business. Of course, we all know free is free. And if I had to talk in terms of realistic terms of what free means, limited service, limited support, limited amount of, let's say, storage space with limited options moving forward across the board before you can actually pay for something that's more robust. Another one is Hightail, another sharing. You can share images, videos, PDFs, presentations. You have limitations up to 250 megabits of storage. And of course, to do more, you have to pay more. Now, please keep in mind, some of these services, until I researched them, I didn't know that they were in existence, because the ones that I've pretty much used for the duration since I've been file sharing personally are either probably Google Drive or Office 365. Another one is Box, with the features of collaboration, file sharing, and these mobility, security, and content management. You have different plans. Once again, if you look at the free, they offer 10 gigs of storage with a limit of 250 megabit upload of an upload file limit. And I'm almost certain that's probably the same, if not less, if you had to email something through D2L. Dropbox, and I'll just give you a perfect example regarding this one. I was redoing someone's PC. I left my storage media at home. So the best option is to access the internet, move content to an area that I could keep as a backup. And I use Dropbox. I set it up with a 30-day subscription, move files. As soon as I loaded a new OS, I moved the files back to the computer and never used it ever again. But once again, this here also offers similar features as the ones mentioned earlier with regards to the differentiation of the plan. And as you can see, 2 gigabits of storage is the basic. And at the basic level, I believe they give a limit of 30 days before you can no longer access Dropbox. If we had to talk about Google Drive, this is what I'm probably most proficient with specific features at the personal level, where the limitation is about 15 gigs of storage. You can do file sharing and access to specific other web apps such as Docs, Sheets, Slides, and Forms. And those are the differentiated plans if you wanted to move forward past 15 gigabits of storage. Okay, there's something else called minus. You get 10 gigabits of free storage, upload files up to 2 gigs, and that's important as well, because if you have a 20 gig limit, then if you're trying to push a 30 gig file, it just won't upload. Unlimited downloads and transfers, publish and share files. You have a dashboard for management as well as a mobile application. There's another one called Spider Oak. And once again, these are some options that I'm not too proficient with, but after reading more about this one is more robust than the others that I've mentioned with regards to security storage that can be encrypted. So if you have to encrypt data, encrypt your folders and files, this is probably one of the front runners that's recommended for security as an option, especially if you're dealing with compliance, such as FERPA, such as HIPAA, and let's see what other compliance. There's other compliance, and we'll talk about this in a minute here, such as being in compliance for ADA or 508, but that's more so to promote universal access. OneDrive, that's Microsoft's version. It used to be called SkyDrive. They have that cloud version that's offered at a business plan. You have a plan 1 and a plan 2. There's also an educational model. K through 12 institutions use O365 as well as Google for Education, and higher education institutions use this as well, either at a free service or at a really low rate type of service subscription from year to year. One thing with regards to these plans, whether if it's that first plan or the second plan, you can sync files, you have a mobile application and data loss prevention. The only differentiation really is the amount of storage that you'll be utilizing. Another one, this is SugarSync, another one that I've researched as well, where pretty much does the same thing as the other instances to which I've rattled off concerning avenues of opportunity for personal file sharing at the enterprise free level. Amazon also has their service. The 5 gigs used to be for free. It's no longer an option, where you could either do photos at $11.99 or unlimited everything at $60 a year. Okay, if we have to look at the file sharing pros, the pros across the board are actually reduction in costs, saves time, better accessibility, recovery of lost files, and files can be accessed anywhere. But I'm going to challenge those options of reduction in costs and save time, because if you bring this more so into the enterprise level, it's more of a transfer of services and support from being in-house versus to providing that same or similar support to the cloud, or maybe a hybrid model. So it's really differentiated. And once again, we talk about enterprise as well as enterprise free, where these are pretty much common ground as far as the pros are concerned. Now let's look at the concerns. The concerns of using cloud services to house files and folders, whether if they're personal or professional. There is data theft. There's a potential for data theft. There is a potential for data loss. Your data can be corrupted. Potential lawsuits. And as we spoke about earlier, being in compliance, whether if they're FERPA, whether if they're HIPAA, it could be ADA or 508 to promote universal access of people with disabilities. It can also be loss of accountability. And we'll talk about that in just a second. loss of file access as well as privacy. And here, bottom line, if we're in the cloud and we have all of these different avenues of opportunity to store our files, where are they located? And some of these options, and I'll give you a perfectly good example. There was one avenue of opportunity I really wanted to research because I'm an open source operating system fan. Ubuntu One, that was an option which is no longer available. So that falls in the category of here today and gone tomorrow. So as much as we talk about all of the positive aspects of getting to the cloud and utilizing the cloud and leveraging this as a shared resource, as a shared platform, have we actually thought about, okay, what do we do as far as an exit strategy if this thing was going to be dissolved? Okay, let's look at issues with file sharing. In 2012, Dropbox employee passwords reuse led to the theft of 60 million user credentials. Okay, now let's look at the next issue. A 2015 data breach study reported healthcare breaches carry a high price tag of $633 per record loss and 154 of other document types as a result. So let's just take the first two bullets into consideration. Let's say we had to pay out 60 million users for a data breach of $154 per user. That right there, if you did the math, ladies and gentlemen, we're talking about $9 billion, that would have to be, resolved with regards to this specific data breach. That's how much it's costing on average these organizations to mitigate these risks, deal with these risks of information that had been lost and information that had been breached. A study by the Honmine Institute on data loss and compliance violation, and look at this, folks, showed employees routinely violated IT policy to get things done faster. So with regards to this, we have to look at the avenues of opportunities once again. Why are we committing to the cloud as a resource to share projects, to share, let's say, privileged information? And also, it reported that 6 in 10 respondents admitted of having often or frequently accidentally forwarded files to individuals not authorized to see them. Mistakes happen, these things do happen. So folks, you have to take into consideration whether it's enterprise, whether it's enterprise free, who you're giving your information privilege access to from any of these shared repositories that we spoke about. Now, if we have to look at any type of recommendations, and earlier we talked about file sharing from an enterprise free, but if you take enterprise free and you take into consideration policy and procedure as they relate to enterprise systems, there are certain things that you need to be mindful of before you commit to utilizing these specific resources on a personal level. Research the different types of security options. Is it encrypted? What type of software do they use for end-to-end encryption? Review the terms of service and disclaimers regarding the intellectual property and ownership rights. And once again, you have to look at the aspect of we're going to the cloud to utilize this platform and leverage this platform as a shared service for other people working on our potential projects. Okay, now the information is out there. What do we look at as far as an exit strategy if we're not going to be utilizing this anymore? Or in some instances, like the example of how I use Dropbox to upload files as a backup, and I downloaded and deleted everything. I don't remember myself dissolving that account whatsoever. So it might still be in existence, but it might just be disabled. Review the privacy policies. And we've talked about this earlier because whether if you're enterprise or enterprise free, you have to be in compliance. These organizations do have to be in compliance with ADA 508 and HIPAA if these were, let's say, public entities like public K through 12 institutions or public higher education institutions. Direct links. Can direct links be associated with file sharing? And some of these options that we've discussed earlier actually have ads that scroll as you use these products. And a lot of them, from the research that I've done, the ones that are free, you're going to get the ads. You start paying for it from a pro version to a business version, the ads no longer exist. And let's look at this perspective of long-term storage. Is this solution going to be a solid long-term solution for you personally, or whether if it transition to a professional role? And here's the last piece here. How about the support for these products when you have problems? So these are, once again, the different recommendations that I would recommend moving forward when you're utilizing these enterprise-free solutions that are offered to anyone over the internet. And I'm going to follow it up with the references. And before we conclude, are there any questions?
Did you have a chance to review any non-enterprise solution?
Yes, it was non-enterprise solution, but I can also share. I also have some notes that I was going to talk about, but I didn't know if you wanted me to talk about this. I went to a One USG Enterprise Cloud meeting back at Middle Georgia State College, where the CIO from Kent State University presented leveraging the cloud. And if you would like, I'd like to show the notes as well.
Yes, please.
Okay. With regards to the notes that I took concerning a cloud event that occurred at Middle Georgia State College, we pretty much talked about different avenues of opportunity collectively through delivering enterprise-wide solutions to students, to faculty, to staff, to administration, from the One USG level, as well as different models that we can also deploy locally at each one of the USG institutions. Certain things that we need to be aware of are, the first thing is the legal contracts, third-party contracts. We have to modify and look at liability, such as data loss or breaches. Who's going to be responsible? Who will be held liable? And utilizing specific language that will differentiate this agreement. And when you look at the clause for a potential clause, being able to remove data at termination of contract, retrieving data from the system. As much as we talk about leveraging cloud solutions that can add value, no one ever talked about specific exit strategies. We're up here now, we're going to move to something else. How are we going? What is our exit strategy to migrate or transition from one sharing solution to another? Also have to look at the SLAs and outlining outages, performances. And in looking at these contracts, how long will the contracts exist? How will upgrades occur? Who's going to own the data? Who's going to protect it? The data, I mean, as far as the repositories, are they PCI? Are they HIPAA compliant? And what we mean by PCI compliant is payment card industry compliance. For example, let's see, the NIST. If you look at the NIST rules and regulations concerning segmenting networks, a recommendation for conducting any type of let's say payment transactions would be systems that would be segregated on separate VLANs for this. And I'll give you an example. I know one institution right now in the USG system that has pretty much one VLAN, and they're doing all the traffic on one VLAN, which is disappointing. Another aspect here we look at is information security. Will the vendor provide full disclosure of events that affect our institutions from discovery to mitigation? The privacy pieces, the data usage. What are you going to do with the data? Who controls it? Can they meet the minimum, the minimum standards from the IT handbook that's still in draft mode? And when you look at the different solutions that are offered that could be leveraged. We have to also look at cost. Is there a cost savings? And I think I spoke to this earlier where within an enterprise solution, the cost savings is pretty much non-existent, where you're now taking your enterprise solution and you're scaling it to the cloud or creating a hybrid model to the cloud. And there is not necessarily a cost up front, but there's a cost in professional development and keeping up with the latest trends on cloud technologies, and people who once used to be, let's say, Active Directory administrators, furthering their training to deal with or to support ADFS in the cloud or cloud, let's say, extended avenues regarding repositories for file sharing. Now, when we look at software as a service, how do you control proliferation? Do you validate a SaaS vendor in order to prevent data leakage? Once again, we're looking at pieces regarding security, the vulnerability, the load, and any associated reports. How do you gain access to data if managing employees leave? These are things on an enterprise level to which you don't just take into consideration the end result, the file sharing option, but you have to also take into consideration the resources and support on the front end to support an enterprise-wide network and to support users on that enterprise-wide network. Should an agreement notification process be created for the end users of the company? And once again, with regards to this, I can give you a perfect example. I know of one institution now where the acceptable use policy needs to be updated. The acceptable use policy does not reflect cloud sharing repositories. I can also show you an institution where that specific project of, let's say, O365 was rolled out and there was no professional development. It was no professional development up front. It was pretty much the buggy before the horse, so to speak. So these are things that you also need to consider. Where will the data be backed up? Where will the location be? I'll give you a perfect example. In conducting research on the back end of all those file sharing avenues of opportunity, the only one that I could really find research as to the nuts and bolts getting into the weeds was with Microsoft Office 365 with their Azure backend, where their backend is hosted in specific regions. It is to the extent regarding their documentation that even DoD, government, have their own segregate repositories for an Azure secured file sharing backend. Okay, under community versus commercial cloud, public and private cloud, will be the transport mechanisms. What standards will be deployed by the USG? What tools can be leveraged to analyze workloads between the cloud and facilitate ease of use and manageability? Is USG willing to serve as a private cloud vendor for institutions within the state? Does USG have an appropriate infrastructure, network, bandwidth, throughput to accommodate this type of deployment? How will federation be handled? Okay, that's what we're talking about, extending privileges, authentication. Right now, and just with the USG, you have some schools that are doing single sign-on and some schools that are not. So once again, there needs to be a common denominator for deployment of services. What requirements regarding data classification will need to be implemented or revised? Here we go. This is a really important one right here. Contingency plans. As much, and I keep circling back to this, as much as we say we want to leverage these specific systems and go to the cloud to make things more efficient, what are our contingency plans if things don't work out the way they're supposed to? Staffing and skill sets. Will the USG as a system institutions pull together to get the resources needed to offset costs regarding training, collaborations, or skills. And for some people who don't know this, there are some aspects of USG, let's say ITS, where the systems that are used at Georgia Southwestern State University, some of those systems are shared, some of those systems are hosted by ITS, where once again, the cost is actually divided at the ITS level and is invoiced to the school level. How do we identify skill sets? Basically, how do we become more proactive and dynamic as a support chain to, once again, we want to leverage these tools. We need to put the support as a baseline in front of it in case anybody has any issues. How will funding resources be obtained for personnel? Retention. How do we establish knowledge redundancy across the state? Will there be a centralized resource available for cloud implementations? Will cloud contracts include training IT functional area users? How can staff members embark upon cloud service agreements and learn about USG resources available to assist? How will cloud implementations affect all IT networking, security, applications, and support? See, folks, it's more than just about taking and leveraging an avenue of opportunity where, once again, you have to take into consideration a specific prerequisite baseline, and it starts with service and support in everything that we've defined here within staffing and skill sets. How to bring non-IT staff up to speed on cloud resources or cloud services. How do we define and establish these job descriptions? And how do we adjust job descriptions and job codes to reflect new skills? Now, I'll be perfectly honest with each and every single one of you, where a job description for, let's say, a USG system school, job descriptions evolve, especially if they're in the IT arena, where IT is consistently dynamic and is consistently changing, where the skill sets of these people who were, let's say, employed, who were proficient with these legacy systems, need to be more dynamic with their approach to learning new things as it relates to leveraging cloud resources. Okay. And once again, these are other recommendations here under the enterprise cloud. Positive experiences across the board from this meeting with CIOs across USG systems, USG schools within the USG system. Google and 365 have positive experiences. And Georgia Southwestern uses Google. Georgia Gwinnett College uses O365. You also have to take into consideration, once again, the confidentiality, the integrity, and the availability. Disaster recovery, what's the maximum downtime? Is there a test or development? Before we actually push anything into production, it's always best to have a sandbox or a development environment to which you can test patches, test functionality, conduct what's considered usability before deploying enterprise-wide into production. Auditability and security. If this were the family feud, folks, number one is security, because a proactive approach towards preserving the integrity of any enterprise network or any enterprise solution is through security. Maintaining maintenance windows. When are the maintenance windows? What are the downtimes? When can upgrades occur? Are they overnight, over the weekend? And this is not a common denominator amongst all USG systems. Every USG institution, every institution's culture is different. Every institution has a different way of doing business. Not every USG institution has to provide 7-day-a-week, 24-hour-a-day support because of distance learning. There are still a few colleges out there in the system that don't offer distance education whatsoever. Communication strategy. How do we get the word out concerning maintenance, concerning issues, concerning professional development? And back to this point here concerning the sunset clause, what is the exit strategy? How do we migrate off? How do we leave? We don't want to use it anymore collectively. How do we walk off and move on to another solution? And the cron jobs, these are just specific scheduled jobs that need to occur for updated information For instance, cron jobs could be scheduled scripts that take banner information and update O365 or update Google Apps, Google for Education, regarding Active Directory credentials to access these third-party systems. So with that being said, we'll go back to the last slide. These are my references concerning the presentation. Are there any questions before we conclude?
No, thank you.
Okay, thank you, sir.
All right, do you have the next presenter?
I'll go next. I'll
All
go
right.
this time. Yep.
Go ahead.
Okay. Let me share my screen.
And what's your topic?
It's paradigms, different paradigms of distributed computing. So, can you guys see my screen?
Wait a second. Yes, we can. I can.
Okay. Hi, hi all. Today I'm presenting the topic of different paradigms and comparison of different models and architectures in distributed computing. So let's start over here. So what is actually distributed computing and a distributed system? So let's start with the distributed system. A distributed system consists of multiple autonomous computers or a group of computers that communicate through a computer network or a cluster of nodes. So that is called a distributed system. And in a distributed system, hardware or any software components communicate and coordinate their actions only by message passing. So that's all about distributed system. And the term distributed computing means spread across the network. It is basically an activity performed on a distributed system. Any action, communicating from one system to another system, it's called a distributed computing. So why is this distributed computing so important nowadays? So the main reason is that this distributed computing utilizes a network of many computers, each accomplishing a portion of an overall task or a computation to achieve a computational result, which is more quicker than any other and achieved by a single computer. So it is very important nowadays, being on the distributed computing, mainly in the areas of big data. So let's start with the basic components of distributed computing paradigms. So today I'm going to cover these various paradigms. So one of that is message passing, and this is very basic paradigm in distributed computing, where data is sent between two processes via send or receive commands. And the next one is a most popular or very well known paradigm, that is client server model. So which nowadays enterprise applications or any web applications using. So in this, the server provides services and waits for its client to connect it, and client issue the request, whereas the server responds with the response through a HTTP protocol, any other protocols. And the next one is peer-to-peer. So as yesterday Preeti explained about the peer-to-peer computing, it's similar. There are some similarities between peer-to-peer and client server model, but whereas into client server model, server acts as a centralized machine, but into peer-to-peer there is no centralized control, but each peer acts as both client and servers. And the next one is message-oriented middleware. So this is a very important paradigm nowadays, where enterprise applications are achieving. So it is a messaging system which handles all messages to communicate one point to another point. So in this message-oriented middleware, there are two sub-paradigms, namely, but very most important. One is point-to-point, and the next one is publish to subscribe. The next one is remote procedure call. So it's basically a function that calls executor it invokes a remote method which is on the different network or in the different platform through a continuous protocols like SOAP. And the next one is distributed objects paradigm. For example, Java, Arm, and Cobra, where objects communicate to another process objects directly. And the next one is object spaces, where the object are located in a common object space, and that can act, and the end clients access that object space instead of directly communicating to the another system. And the last and the least is mobile agents, where a piece of code is traveled to different nodes or different nodes in a cluster, or different computers in a network, or to host and get some work done. So that's the mobile agent. So let's start with the basic messaging model, that is a message passing model. So this is a basic and fundamental paradigm for all distributed applications. Yeah. In this, just a process sends a message representing a request. Maybe let us assume there are two processes, A and B. So A sends a message representing request to B. So the message is delivered to a receiver B, and which processes the request and sends an immediate response to the A. Okay. So in turn, the reply of may trigger a further request, which leads to a subsequent replay, and so forth, maybe kind of a loop. So the best example for this is what we developed in the first project in assignment 1. So the PC, IO, and worker module especially, the best example is the implementation of SMTP server, where we send hello request to another process. It then it replaces with the host name, and it leads to a subsequent commands like recipient, mail, these things and all. So this kind of thing is a message passing model, and this is a very basic and fundamental model for all distributed applications. Okay, it involves two separate independent process, or many independent process, where client can access the pass messages to process B, or so many several threads of A can access and pass messages to process B. And the basic operations involved in this is just send and receive. And the best example for this is socket programming nowadays. So it's very well known program for all. So it contains implementation of basic message passing model. And the next one is the client server model, where it is the best known model or architecture model for any web applications or enterprise applications nowadays. Unlike in the message passing model, in this model, every process assigns an asymmetric roles to the collaborating process. Suppose, for example, client and server. So server has been plays a role of service provider, which waits passively for arriving the request from the client. In other, the client issues specific request to the server and waits for its response. So it's kind of synchronous. If you see this one, so let us assume this one is a client, which is maybe any kind of browser, and this is a rack of servers, and client accessing their request to the web server, and web server further access or manipulates the database and gets data from the server, get data from the database, and returns same response to the same client. So in this case, there is only one client and one web server, but in practical scenario, there will be many clients accessing a single web server. Maybe the centralized system where different clients, even from the web or mobile or anything, so can access the web server. So this is a typical client server architecture nowadays, was the enterprise application follows. So the client, which contains any GUI representing kind of HTML things, or any mobile UI, or any iOS device or anything like that, so which access the server application by means of any HTTP request or AJAX request. So the server process the model and access the database and get the models from the database and perform some validations and some other stuff using some filters and give us the response or with any format, like it serves as a HTML response, or any JSON or any XML response to the same client or in a different client. So this is a typical architecture for client server architecture. So but this is similar to message passing, but unlike in message passing, in client server architecture, there the client and the server has been assigned to asymmetric roles, where the server has only playing the role of accessing, waiting for the client request, and where client access only passing the request to the server. So It's about client server model, and there are various protocols involved in the client server model where the client interacts with the web server using some HTTP or FTP commands. There are some other protocols, but the mainly used protocols are HTTP and FTP. And there are number of architecture or design models in client server model nowadays, which the different MVC framework implements. The most commonly used design pattern is two-tier architecture, and later it come with entire architecture. And nowadays, all web applications are following the MVC framework, which has an three-tier different tier of architecture, where model view control says uh, there is a loose coupling between the presentation and the model layer. And the client, it seems, says it can the GUI can has some HTML or XSLT or XHTML or faces markup languages where it uses a scripting kind of thing, and it's kind of JavaScript or any other latest technologies like Angular JS to communicate with the server. And the server may be implemented based on different dynamic scripts. Maybe in earlier days it's a CGI script. Nowadays, applications are using JSP scripts when PHP or ASP scripts. So this is all about client to server architecture. And the next model is the peer-to-peer. This is a very most important paradigm in nowadays. It's similar to client server architecture, but whereas in the client server there is a centralized server which take controls of different clients or different sub servers. It's a centralized architecture. But in the case of peer-to-peer, in this system architecture and networks, where computer resources and services are directly exchanged between computer systems. So these resources and services include exchange of information and some cache storage and some disk storage for files. So what it looks like is there are independent hosts or computers which will be located in this same network or in the different network or in a different location. But each peer can talk to the another peer. So each peer can act as both client and server. So there is no centralized control of this model. So any peer can contact with any other peer. So using in the peer-to-peer model, using a algorithm called distributed hash, and there is some routing algorithms. So the one peer can contain some routing information about other peers, where it can get some file sharing, or it can get some information about what the peer wanted exactly. So it goes around. So any peer can communicate. Any peer should contain some information, routing information about other peers. So this kind of thing. So it's not a centralized architecture. It is a decentralized architecture where peer can directly talk to another peer instead of peer. Likely in client server architecture, clients talk to server and server talks to another client. So in this, the system talks directly to another system. This P2Me model, all nodes are, all nodes acts as both clients and servers. So there is no centralized control, and all nodes are act as autonomous in this network. So network is dynamic, and nodes may enter and leave at any point of time. So nodes can collaborate each other. There are some benefits using P2P networks. So the main benefit is efficient use of resources, where each system directly talk to another system. So there is a vast efficient use of resources in this, and the scalability and reliability and the ease of administration, because of there is no centralized architecture. So the ease of administration comes to picture. So there are mainly 2 or 3 classification P2P networks. So one is centralized systems, and one is broker systems, and one is decentralized systems. The main thing I'm talking about is decentralized system. And there are many varied application areas where P2P is implemented. It's kind of in communication areas and remote collaboration, like WebEx or teleconferencing, or some kind of Skype-based applications, and distributed computing, especially in terms of Hadoop or big data kind of related. And file sharing, there are various applications like BitTorrent, some other areas, some music share, kind of thing which implemented the P2P areas comes to file sharing. So there are some technical challenges implementing these P2P application areas. So the peer identification is a major challenge, and the routing protocols that follow the P2P network which implemented is a major challenge in that. And but last but not the least, the security. So because of no centralized architecture, so the security is very crucial for the P2P networks, where we cannot so if any malicious system can attack any any other system in the network which which steals the routing information and can access any other systems. Okay, this is all about a P2P system. And the next distributed computing model is message oriented middleware or message system paradigm, widely basic called as message system, but implementation is a message oriented middleware, where the message communication between client and server talks here, and the terminology comes around producer and consumer. So producer produces the messages to the consumer, where consumer consumes the messages produced by the producer. But the producer and consumer cannot talk directly to each other, but instead of talking directly to each other, it contacts a message system or any message server, which is called as nowadays there are many implementations of this message system, Active MQ, Rabbit MQ, IBM MQ. This is a message system where it can manage all the topics and queues or channels and each other. So in this message model, there are two types of submodels again. So one is point to point model, and one more is publish to subscribe model. So coming to point model, so any client A which has to send some messages or produce some messages to client B should contact any message server or message system, or usually we call it a service bus. So the service bus typically contains queues and topics. So in this point to model message, the message transformation between one client to another client should be considered as a queues. So client A produces a queue to the service bus, and client B, which is register for the particular queue, get the message as soon as the particular queue get the message from client A. So this is a detailed flow and the down picture here. So whereas the process does perform some action and post some message to the message queue, where another process posts the same message queue to the service bus, and from the service bus a particular consumer which is bind to the particular message you get the message, and the another consumer message bind to the another message gets the another message. So this is a kind of point to point application. But the next model is publish to subscribe. There is a vast difference between publish to subscribe and point to point model. In point to point model, where the communication between two processes happen between like point to point, where only one producer will contact the one consumer. But in this publish to subscribe model, any sender can send a message to the service bus using a message queue. It has a dedicated channel for that. So the receiver 1 and receiver 2, what it does, it subscribes to the particular channel, and whenever any messages from the client get into the channel, it subscribes for that. So a separate channel will be assigned to each receiver, and the same replica of messages will be sent to the receiver 1 and receiver 2, and receiver 1 can process its own request, and receiver 2 can process its own process based on the data what it received. So this is the detailed flow. In this publish to subscribe model, every communication between the producer and consumer goes as topics. So each consumer can subscribe to a particular topic, and whenever it subscribes to a particular topic, any message that will be coming to the service bus through a channel, it will be sent to all consumers. It will be not only to the one consumer. The consumers which are subscribed to the particular channel will get the messages. So for example, let me show you a practical application. Okay. So here is a message system what I'm talking about. So these are the practical message systems nowadays which implement the service bus concept. For example, RabbitQ and ActiveMQ. For the purpose, I use RabbitQ here. So this RabbitQ has it's in a GUI kind of thing. It has all the queues what I'm talking about, and all the channels. So you can see all the channels it contains. It contains all the exchanges. So we can monitor every exchange from client to the server, and all the queues and all the topics. So for instance, okay, so I have a publisher. I'm publishing a message called message publish to the channel, particular channel, right? So I have subscribed 3 channels to a particular publisher. So the 3 channels got the message. Channel 2 received the message, and channel 1 received the message, and channel 3 received the message. So when you go to the admin here, you can see 3 separate queues were created based on that. So everything is running here. So every subscriber got the messages what it got here. If you go to the connections or exchanges and queues, so these are the channel I am talking about. So it got all the messages and published out. So as soon as the RabbitMQ, the service bus, receives the message for a particular channel, it sends to the consumers which is subscribed to that channel automatically. So that the case I got this. There are 3 channels subscribed to the particular thing here. There are 3 channels subscribed to the particular channel here. So whenever I publish the message, as soon as I publish the message, channel 1 and channel 2 and channel 3 gets the same message. So this is the publish subscribe model I'm talking about. Okay, I'm sorry. Okay. This is a publish subscribe model I'm talking about. So each receiver subscribe to a particular channel here, and whenever the sender, whenever the publisher publish a message to the message queue to the channel here, so the same replica of channel created to the each receiver, and message queue is delivered to the each receiver. So this is a publish and subscribe model. So in this type of model, there are few protocols involved in this. So usually the base protocol in this publish and point to point or any published subscribe model follows is AMQ, that is active messaging queuing protocol, and even some service buses is some using like ActiveMQ or SonicMQ supports HTTP kind of request, and even the support for REST. So these the message systems nowadays implemented. There are many various enterprise service buses, but the main things about it is nowadays is ActiveMQ, which is provided by Apache, and RabbitMQ, IBMQ by IBM, and SonarMQ. And the middleware concepts implemented by this message-oriented middleware model is there are some enterprise level of message models like OSB, Oracle Service Bus, and TIBCO, and some freeware kind of thing, Mule ESB, that is Enterprise Service Bus. And the next model of distributed computing I'm talking about is here the RPC, remote procedure call. So in this message model, there is a main topology of here which plays a major role in the RPC procedure call, which is as SOAP, usually called as Simple Objects Access Protocol, which is as simple as like HTTP, the same message structure, but a different different kind of messages. So in this model, okay. So each client, the communication between client and server we call as consumer and producer, right? So producer can give some access to its methods by giving some it's some information about its methods and its objects by giving some contract or kind of document where the client can get the document. So he will go through the document, and he will find that what the method he need to invoke, and he will call the particular method in different service providers. So the main difference between usual message client server, similar circuit programming or Java RMA, and to the remote procedure call is, so this remote procedure call works for all independent of the service provider, whether it is a Java or .NET provider or any Android provider, so whatever. So the client still can access and get the methods by using this method. So because the main communication between these client and the consumer and producer is there is a term called WSDL. This is a strict contract document that the provider gives to the client, which is described as a web service description language. So this document contains all the necessary packages and classes and methods that the service provider have, and the client gets the WSDL document, and he know what he needs to access the methods from the remote service provider, and he can get the particular methods. Coming to RPC call, the major implementations of RPC is nowadays is web services, either SOAP based or REST based services. So let's talk about the web services in a picture here. So where this is a service provider which uploads the web service description language. What is the service he is providing to a UDDI registry, Universal Description Directory interface. So from where the client accesses the WSDL and go through the WSDL document and knows what methods he needs to invoke and invoke the particular method. So let's see the practical example of this even. Okay, so these are the UDDI I'm talking about. So this is the service registry, and this one is a third-party service registry, which is called webservices.com. Here we got a different kinds of web services. Namely, we got a global weather service. When you click on this one, so it has a endpoint URL here, which gives us a WSDL document. You click on the WS document, you will get some XML based structure here, which has what are the methods and what are the packages and what are the objects that the service provider giving access to us. So the client gets the WSDL document. So I'm using a tool client here. Instead of this, usually we do with the Java programming. So but I'm using, for time instance, I'm using SOAP UI, which interacts with the web service actually. So I just got the WSDL and I import the WSDL. So I got the request format. This is the SOAP request I'm talking about. So it is it's a kind of HTTP request, but it has a SOAP envelope and it has the same. So it contains the same SOAP headers and SOAP body. So but in the body we need to pass the message parameters. So this is the method I am accessing about get cities by country. So if I provide the country, so I should get the cities in that country. So suppose I provide India here and I run this program. So I got the cities in here. So the data here, the payload here I got is not from this tool, and I'm getting the data from here. So this is the service it is providing. You can test here, right here even. So this is the data I'm getting from the server here. So this is the main thing. So this is a very most common distributor message model nowadays following. As legacy applications are limited and all are platform dependent, but the web service come to picture nowadays as its reliability and platform independency. So we just develop a service in a one platform and publish it as a web service in UDDI registry. So any client, even from the .NET, any Android client, any client can access the service because it is a pure XML. So XML could be understood by any programming language. So independent of any Java or .NET, so XML can be understood by any programming language. So there are mainly two approaches in this web service to be developed. So one is bottom up and one is top down. So top down approach is that the client and the service consumer and the service provider have a mutual contract So to develop the contract first, and based on the contract, they will implement the web services. So, but whereas bottom up, the service provider develop the implementation, and then he expose that implementation as web service. So that's the main difference between these two bottom up and top down approaches. And the next main important distributed paradigm in distributed computing is the distributed objects, where object orientation to distributed applications. So objects provide methods through the invocation of which an application obtains access to the services. So this mainly involves in object orientation implementations. Paradigms include some kind of remote method invocation coming to Java RMA, and network services, object request broker, and object spaces. So we will discuss these sub paradigms in detail by one. So let's come to remote method invocation, where so we already know in the previous I'm not sure, in the previous semester we have some assignments on RMA implementation, where RMA client locate an RMA registry which is binded to a RMA server. So we, by accessing RMA registry, we can invoke any remote method by using RMA registry. So this method, this is about remote method invocation. So there are various implementation in RMA. So Java provides there is a Java RMA which implements this RMA method invocation. So there are major disadvantages in this particular distributed model. So whereas this as it follows the object oriented, this is limited to a particular platform. I mean, if the client communicates to the another processor or another system which is communicating through by Java objects, so the receiver should be able to understand the Java objects. So this is a major disadvantage. That's why the web services and remote procedure call come to picture, which is in which the communication happens mainly through some SOAP based protocols, which strictly follows an XML communication. So next one is the request broker. So in this, mainly the client application, could not directly interact with the server application. Instead of that, it contacts the object request broker, which is an interface or medium between the client application and the server application. So in this pattern, application uses request to create an object request broker, which directs the request to the appropriate object that provides the desired service. The main advantage of this thing is here, the client can access multiple methods of the server application, because it is directly not communicating with the server application. Instead of that, it is communicating with the object request broker, where object request broker can give access to the multiple methods to the appropriate server. And the object space paradigm. This is a very important and very latest kind of distributed model of architecture. So where provider actually in this process of communication, client cannot directly access the service provider, but instead of that, provider develops an implementation and it writes to the object space, what we call as object space. So from that object space, the requester can read the basic data from the object space. Perhaps the most abstract of the object oriented paradigms, the object space paradigm assumes the existence of logical entities, which is known as object spaces. The one which is here is called an object space. The provider, what it is doing, it is writing the information about what it is providing to the object space, and the requester accessing the data from the object space, not indirectly, not directly contacting with the provider, but accessing the object space. And the last and the least is mobile agent paradigm, and which is very important paradigm for big data applications or any cluster based applications. In this mobile agent paradigm, a piece of code from a client or any consumer can travel to a cluster of nodes. This is a piece of code which is traveling to the cluster of nodes. For example, let's say client sends a piece of code to the cluster node A, and A process some task based on that the bytecode or agent obtained at the node A particularly. So this is a very modern kind of paradigm, where a piece of code to be shared in the nodes of cluster or in a wide area of computers. So where the agent travels across the host from host to host and do some task or do a computation or do a task like that. So the main the biggest example of this paradigm is Hadoop distributed file system, where Hadoop distributed file system sends a jar file to each of its node in the cluster to get a job done. For example, let us consider a big data which contains unstructured information, which needs to be find some find some words in a similar manner, and calculates the maximum number of words or the count of the words in that. So what client will do, what the HDFS will do is it just sends a jar to the cluster which contains a piece of code to execute a task, and each node gets the particular piece of code, and based on the environment in the node, it performs some operation. So based on the big data, so at last what it will happen, so each node independently do some task, and at last it combines all the output and gives the combined output to the client. So that is a mobile and agent paradigm. So these are the main paradigms I would like to cover in this particular session. So I cover the mobile. There are mainly three kinds of paradigms coming distributed. One is distributed objects, and one is message Poisson kind of thing, and one is message oriented middleware. So these are the various distributed paradigms in the distributed computing nowadays, which has its own advantages and disadvantages, and which has its own security concerns, and which has advantages regarding reliability and scalability. So this is our presentation, my presentation about today. So but today I don't have any references for this, because I developed this presentation based on my previous knowledge and work experience. So unfortunately I don't have any sources finding this presentation. So this is about my presentation. Thanks to all.
All right, thank you.
So do you have any doubts regarding this?
I probably just have one comment. You started from the very beginning, like presenting the summary of all technologies, but then throughout your presentation, it was hard to follow where exactly you are on the original outline. So it appeared that it all started with the structure, but then the structure of your presentation got lost through your item coverage. So at the very end, I'm not sure which part you were presenting that was declared at the beginning. So that was for me very hard to follow. But rather than this, I believe you covered pretty much everything in terms of different technologies, and the coverage is really good. But it was hard to follow what you are presenting.
Okay, thank you.
And for other presenters, we still have about 1 hour to complete everything, and try to not to exceed 20 minutes time frame for your presentations. We have 2 more students. Maybe someone else will join us, but let us just try to stay with 20-25 minutes time frame. And who will be next? Anybody still here?
Oh, yes, I'll do it.
Okay. Go ahead, HP.
Okay. So, can you see my screen?
Yes, we can.
Okay. And hello, my name is Hyuk-Pyo Hong, and my topic is a comparison of popular bootstrapping protocols in peer-to-peer network application. So my presentation consists of a peer-to-peer overview and several peer-to-peer network model, and finished with this summary. So as you know, the peer-to-peer is the system or application which is very distributed through the network, and there should be no centralized control server. And the important thing is connection between each peer should be direct interaction. To make this peer-to-peer network, we have to make an additional network layer, which is called overlay, because in real world, every client connected to each their own network and behind the firewall or NAT and so on. So to make it easier to connect between each node, we have to make an additional overlay network.
HP, I'm sorry to interrupt you. You probably want to share the entire screen, not just the PowerPoint application, because we still can see only introductory slide, the title slide.
Oh, really?
Yes, you want to share your screen, not the application.
Okay.
In the Hangouts, when you share something, you want to share the entire screen. It's an option. There are different options of how you can share the screen.
Okay, I changed the option.
Okay, now we can see it and try to, now we can see you changing the slides. Thank you.
Sorry. Anyway, we can make an overlay network to make a peer-to-peer network. And the advantage of making overlay network, with this new layer, this will make a fast and searching lookup of requested information. And also we do not have to make or deploy new equipment or modify existing software or protocols. And the main concept of peer-to-peer, or the first stage of peer-to-peer, is bootstrapping. Bootstrapping is a join new node into the existing overlay layer. And that makes the new node to find, download, or upload resources from the other clients. Main features of a peer-to-peer system is churn. Unlike traditional server and client network, the peer-to-peer system are managed by or controlled over individual users without the public company or organization. So the membership status changes very frequently. So to managing this frequent change is the essential point of a successful peer-to-peer system. So there are several categories to explain peer-to-peer. The first one is unstructured. First one is unstructured peer-to-peer, and second one is structured peer-to-peer. Unstructured means each client have no predefined ID or predefined location to involve the network. But in other hand, structured peer-to-peer has a predefined location for every node, for every resources. And once again, unstructured peer-to-peer system can be subdivided into three category. First one is centralized and homogeneous and heterogeneous. I will explain about all of this in the next page. The first, and one thing to mention about the peer-to-peer is, in these days, peer-to-peer system is not so popular when compared with the global internet traffic. Its share percentage is looks like less than 10%, and annual increasement is less than 10%. And also, traditional popular peer-to-peer application are very decreased around 2010, but still uTorrent, which is the application of BitTorrent, and Skype are still alive in 2017. So I also mentioned about this BitTorrent and Skype. BitTorrent is represented structured based on distributed hash table, and Skype also represents unstructured heterogeneous peer-to-peer system. The first thing to explain is a centralized model. Its representative application is Napster. Napster is the first generation of peer-to-peer which was invented around 1999. It was only for MP3 sharing. Actually, there was some central index server that makes it is hard to say this is a component of a peer-to-peer system. But in that time, index server has a role to managing all the list of resource and all the list of clients. So once some client try to log into the Napster service, they have to register into the central index server, and they have to submit their whole list of MP3 file. And whenever they need other MP3 file, they request it to the index server, where is that file. After then, index server responds with the information about IP address, which has that required MP3 file. Once the client receives the IP address, they can start peer-to-peer communication with each other. So Napster service consists of two stages. First stage is not so similar with peer-to-peer, but second stage can be called the peer-to-peer system. The advantage of Napster was search complexity, or time complexity was a big notation 1, because there is just only one step to ask to the server, or there is only one step to respond to the client. There is no intermediate step between them. This small time complexity makes Napster more simple and faster. But disadvantage is, since we use central server, once this server is down, all the network will be down. So that will be a risk of this system. Also, to maintaining the central server also expensive things. And next model is second generation of peer-to-peer, which called the homogeneous model. Homogeneous model, it is a so-called fully distributed peer-to-peer system, because there is no centralized server, and each peer connected with the equality role. The first application was introduced around early 2000, and its name was Nutella 0.4. Nutella 0.4 has a feature message flooding. So once they required something, they submit this required message to the connected peers. And once the neighborhood node receive the request, they also can forward the same message to their connected node. And there is some concept of TTL, which is time to write. Original version of Nutella has time to write 7. 7 means each message can be forwarded within 7 steps. So after 7 steps, the message will not spread anymore. The workflow of Nutella consists of 3 steps. First one is ping and pong. Ping is the attempt to make a new connection with the existing layer. So new node send the ping to the existing node, then the receiver responds with the pong message. Once the pong message is received, they can make a peer-to-peer connection. After that connection, the new node can send a query message to find the required resource, and if some other client have the required resource, they will respond with the query hit message. After original client receive query hit message, they can make a peer-to-peer resource sharing with the HTTP protocol. So this is the picture about that process. New peer send a ping message to the neighborhood, and he will respond with the pong message. So after that, they can make a peer-to-peer connection, and this ping message also shared with its neighborhood node, and they can also respond with a pong message. After then, each of them can make a direct connection. But the problem of this model is to make an initial connection, new peer have to know at least one address of existing node. So at that time, people said they have to find the member information from the web host cache or telephone or from the mail. So it is very inefficient and very inconvenient way. Another problem of Nutella is a lot of traffic. Since the original version has time to arrive number 7, and if each step has 8 connected nodes, the total number of messages spreading will be around 1 billion. So that will be a very traffic waste. And if there is no required resource, it will be also traffic waste. So I found some survey from that time, and most of Nutella traffic consists of ping and pong messaging. And the traffic related to the file sharing is less than 1%. This makes the time complexity very higher. It will be almost exponential big O notation. And also there was a problem related to the free rider. Free rider only just download from other clients, but they will get away from the network with that resource. So to improve this homogeneous disadvantages, heterogeneous model was introduced. The representative application is Kaja model. Kaja model is combined with the previous Napster and Nutella model, because like Napster, there is a centralized server which called supernode. Supernode can manage its sub-client from here, and each supernode can communication with the other supernode. So they can reduce much more than previous Nutella model. And next one, the advantage of this heterogeneous model is very popular at that time, and especially in Europe, there was not strong law about the copyright of resource. So it was very popular, especially for illegal resource sharing. But the new problem was emerged because entertainment companies tried to spread fake data onto the this Kaja application network. So users became very tired about downloading fake data. So this Kaja application decreased more and more. But the algorithm or model of this Kaja model was so useful. Initial Skype model also adopted this Kaja network model. So at that time, each Skype client can access to each super Skype node, and each Skype super node can communicate with each other to find the opponent's contact information. Next model is a structured peer-to-peer based on distributed hash table. The representative application is called. They used a large scale of hash table. That hash table has a lot of location to assigning the resource and node into the specific ID location. So for example, to make an ID, called adopted SHA-1 encryption. SHA-1 makes a 160 digits bit ID. So in the hash table, we can see the location from the 0 to location to the 160. Its number of digits is 48, so it is much more than full address of IPv6 IP address. So for example, if a first node has an IP address like this, it can be converted the SHA ID 2031, and this IP address can be assigned to the hash table. And also, this node can have a resource which name is hazed.mp3, and this file name can be converted to hash value, and it also assigned to its location. And another node can has a different IP address, and this IP address can be assigned to the same address. Then after that, if another node wants to access to this file, they will firstly convert the file name with SHA-1, and they're looking for this node, and they will ask to this IP address whether they have this file, and they can start the peer-to-peer sharing. Professor, excuse me, may I ask how many time I have?
You go ahead. You have enough. 15,
Okay.
15 minutes you can count on.
Okay, I see. The problem is I'm sorry. So how can you node can detect this ID number has this IP address? So there is one special table which is called the finger table. So each hash table ID has several IP address, almost 7 or 8, and whenever they try to access to the required location, they will try to access to the most closest IP address. After then, they can find another finger table from the new address. So like this, if we start from 709, and this position can has finger table location 1, 2, 3, 4 location. So if we want to access to this 3, 4, 8, 5 position, it will jump into the most closest position, and after that, it will see its new finger table to find the most closest position to 3, 4, 8, 5. And another example can be like this. If there is 17 peers in the network like this, and the number of each finger table has 7 labels. And the formula to make finger table location, for example, we can see the finger node 10, and 10 plus 2 to the 0, 2 to the, until the 2 to the 6. And that can make each computed value, and it has a specific hash table location. But there can be an empty node between the existing node. So some node can control the several empty locations. So in this example, if we want to find the 26, but 26 is an empty location, but it is managed by existing 31 node. And another example is from the 1008, and we want to find the resource ID number is 3000. Firstly, we can jump into the most closest position 2207. After then, from this finger table, we will looking for more closest position here. After then, we will access to the most closest position which can manage the required resource. So all these finger tables are called distributed hash table, and that makes reducing the time to search required resource or required node. And for the bootstrapping, if new peer has a specific IP address and with SHA encryption, it will be converted 1289, and then it will contact to the existing network and find if there is an empty position for 1289, and this client will be managing this space for other clients. The advantage of these code models, they have a good scalability, which has a time complexity log n, and it was very popular to show the main idea of distributed hash table. But the disadvantage of this model, they are one-directional communication, since they cannot backward to the communication. To improve this one, Cademilla model was introduced, it can make it possible to communicate with bidirectionally. The main idea of Cademilla was use XOR matrix to compute most closest distance between each node. So since XOR have a same value regardless of order of node, A XOR B or B XOR A has the same value, they can communicate with bidirectionally. I said about this. And with the XOR distance, for example, here is our current node and its address is 0011, and we want to find this 1110 position. And each node has a small finger table which called the K-box table. K-box table has several IP address, and if we want to find this position, we compared with the distance with the XOR, and we can find the most closest distance from here. Then we can jump to some region, and from that position we can calculate a new distance, and we can narrow the search scope, narrow. Finally, we can find the correct position. So it is also have a time complexity log n. So it is much advanced from previous network model. So this model was adopted by BitTorrent. Actually, when BitTorrent was developed for the first time, there was a tracker. To use the tracker, user have to access to some web page to receive the torrent file. With this torrent file, client can access to the tracker, and tracker will respond with information about IP address which client have that required resource. So they can connect to the several peers to download simultaneously. But for example, piratebay.com, so many tracker websites are closed by police because they deal with illegal resource. So BitTorrent try to make a new way not to use a tracker system. So, for example, if we can see the torrent file, we can see this information, so name of file and creation date or length or number of piece and size of piece. The most important part is here, hash value of each pieces. So with these hash values, we can try to find the correct location from the full hash table location. So this time complexity is log n. So for the summary, I explained about the peer-to-peer system, unstructured 3-category system, and structured based on distributed hash table. And the first model of peer-to-peer Napster has, although they have a big O notation 1, since there is a very short transaction between server and client, but they have a lot of node state between the client and server. It was a big problem that time. To improve this one, Nutella type, although they have a small node state, they also has a lot of ON to find the required resource or required node. So the most advanced model is the distributed hash table, which is adopted by BitTorrent. So it has most less time complexity nowadays. Okay, so this is the end of my presentation.
All right, thank you. Do you have anybody else for today?
Yeah.
Kai?
Yeah, I have a
You ready to speak?
yeah. Can you guys see my screen right now?
Yes, I can see it, but yeah, you do it the full screen now. You want to, yeah, it's okay. I can see it now.
Okay, so my topic is, oh, can I start right now?
Yes, please.
Okay, thank you. Hey guys, this is Kai. My topic is WebSocket versus a traditional socket program prompts. And so the content I'm going to talk about today is divide like first I'm going to introduce some like background knowledge, just a very simple one. And the second I'm going to talk about the socket. Then next I will going to talk about a little bit about HTTP. Then I will go to the WebSocket. Then at the end, I will compare the socket with the WebSocket and finish my our presentation today. So first, let me introduce about a new not new concept actually, just like a really common concept or OSI model. So no matter what kind of no matter we're talking about a socket or web socket, no matter what kind of, it's all about communication with the client side and to the server side. It's all follow this OSI model. So the OS model, according to the definition of the OS model, is the full name is Open Systems Interconnection Model. It's a conceptual and logical layout that defines network communication used by system opens to interconnection and communication with another system. So this model has been divided like 7 parts. So every day we connect, we going to visit the internet. This whole model just has been, So the first model is physical. The first layer is a physical layer. This layer is actually just like the picture showing, is for turning to data into an electronic signal by the physical medium, like the devices. And the second layer is called data link layer. This layer actually is for deciding how to visit the internet. Like, are we going to use a router or adapter? So the third layer called network layer. This layer is most complicated layer in this model because first, this layer has to use a different kind of algorithms to determine to decide what, for example, like IP address. Then is this layer exchanging the data based on the different rules. Like then finally this data will be transformed to the package and sent to another internet device. And the fourth layer is called transport layer. This layer is mainly to build a reliable connection for data communication based on the different protocol. Like the most protocol we are talking about is like a TCP and this kind of a protocol. The fifth layer is called a session layer. In this layer, actually, this layer controls the connection between the different computers, like first establishing or terminating the connection between the local or remote application or client and server. So the socket we're usually talking about actually work on this layer. So the sixth layer is called the presentation layer. Just like its name, presentation. This layer mainly for establishing the context between the application layer entities, like mapping service or translating between application and network formats. For example, we can encrypt our data on this layer. Basically, this layer can transfer the data into the form that the application is able to accept. So the final layer, seventh layer, is called the application layer. This layer is close to the end user. We basically deal with this layer every day when we were using our browsers. So this is an interface for the user's application, like browsers and the internet. So basically, no matter what kind of a connection we try to use, this model happens every day. So the next thing I'm talking about is socket. So well, the first question you're probably gonna ask, what is a socket? So the socket is actually the endpoint of the two-way communication link between the two programs running on the network. Now, it doesn't matter if this from a service or client or from the different applications. The socket always running. So there's a saying that socket connects everything. It's a little bit dramatic, but it's kind of true, partially, well, maybe 90% true. So basically, there is a client side and there's a server side. The client side have their own port, and the server side also have a port and IP address. So the client side knows that the server side port and the IP address. So the client side will be sent to the request first. Then the server side get this request, and after identifying this client is is safe and is not the hacker, and it can be safe to build a connection. So the server is going to respond this connection to the client, and they are officially built a connection. So what this is just generally speaking. So let's look into the details. So in this example, I'm just going to use the more commonly connected socket called socket based on a TCP/IP. So basically, there are two sides: client side and the server side. So the client side, on the client side, the clients know that the house name of the machine, which the server is running, and the port number on the server is listening. Like the server side, they have find the the socket and listen it. So and waiting for the connection from the client side. And to make a connection request, the client trying to assign with the server on the server's machine and the port, and the client also need to identify himself to the server. So it finds the local port number I was using during the connection, and this is usually assigned by the system. Back to the client side, or server side. If the server finds the connection and respond this connection, and the client and the server side officially build a connection, and the client can just write the file and send to the server, and the server read it and rewrite it and respond back, and just like a circle. And after the client side finally finished everything, okay, and the client side close, and the server will be just holding to the request and waiting for the next client until the server side got closed. So usually there are more than just like one or two different kinds of sockets. There are like socket based on TCP or UDP or SCTP, But today I'm only going to talk about the socket based on the UDP and the TCP, because these two types is common, usually mentioned by people, and most people are familiar with these two types. So basically, the full name is called the datagram sockets based on the user datagram protocol. So this kind of type of socket provides a kind of called a connectionless point for the sending or receiving the data packets. And another called stream socket that's based on transmission control protocol. So this type of socket provides a connection-oriented, sequenced and a unique flow of data without a record boundary. So how we can understand these two different types of sockets? So here I'm going to make a really simple example to let you guys understand what's the concept of these two different types. So okay, let's first talk about the stream socket. So how exactly a stream socket is more like we making a phone call between the client side and the server side. So so the server side places a call and the client side answer, or client side place a phone call and the server side answer. Two sides can just say hello, and after they say hello, that means okay, I'm here, I'm going to talk to you. Then they kind of just two sides can starting to exchange the information. Once the one side once the client side is down, say okay, I'm done, I'm going to leave. then the server side just say goodbye, and you can just connect disconnect the connection. Or but if the client side actually accidentally lost connection from the server side, the client side will be automatically connect again, trying to connect to the server again, reconnect to the server again. So basically, there always will be like a guarantee that data will not arrive in a different order than you send it. Also, the data also can be, cannot be damaged during the whole connection. So it's safe and it's guaranteed. About the data socket, datagram socket. So compared with the stream socket, the datagram socket is more like passing a note in the classroom. Hypothetically, we want to pass note into a classroom, but you will never, you cannot just directly to connect to you cannot directly connect to the destination. Like you cannot just send a message immediately to some certain classmate. You have to ask someone to help you to deliver this message one by one. So the node will be travel from the person to person. Hypothetically, if I want to send a message to home, I have to send a message first to Aslam first, and Aslam just give home next, just like this one. So basically, this is faster than the stream socket, but you can obviously think about this message during the passing the process. This message can be damaged or modified. Like while I told one thing to the someone, and later he just give a totally maybe a wrong information. So there's no safe guarantee for this kind of a transaction. But for the stream socket, usually we use like file transaction. Hypothetically, like you're trying to transform the file from this application to another application on your phone or on your laptop. So during this situation, we prefer using the stream socket because it's safe. You guarantee that all your data can be transformed and without damage. But when we're playing a game, you can be just like broadcast some message to everyone. Well, you don't care about the message if the message can reach the final destination. You only hope that this message can be sent as soon as possible. In this case, we just use the datagram socket. So after we're talking about this basic two different types of socket, we can just consider about the advantage of this kind of a socket. So first of all, it's flexible and powerful. Like I mentioned, the two simple example. Like it's flexible because the stream socket can just pass the data with the guaranteed safety, and it's powerful, and it can just use a different kind of a transportation protocol to transport your data. And also another advantage is short transfer time. So we have a datagram socket. You can just pass the information or message as soon as possible. It's really fast. And also there's more suitable for CSCI solution, like client and the server solution. Like before back to maybe 10 or 5 years ago, people were still using this kind of way to connect the server. Like people connect or open a website and check and connect to the server and get the information they want. So this is a pretty old-fashioned way. Also, we can use this way to encrypt our message. We can use a different kind of algorithm or hash to trying to encrypt, make our message or information more safe. But obviously, there is some disadvantage of this technology. First, is need to analyze the data. As I mentioned that before we transport everything, we need transfer the data to a different kind of formats, so they can just transfer between the different different devices. So that obviously you need after in order to receive this message, you need to analyze that data. So, and another thing is obviously the higher level expertise. So it's not like a really simple one. You can just click send and go to another site directly. It's not like that. The socket we have to do use in our programming, like Java, C#, has to require the developer have at least the basic knowledge. And the third disadvantage is increased complexity compared to HTTP. HTTP is pretty normal, usual connection method between the back to like 8 years ago before the WebSocket developed. So this is HTTP is a mainly connection. So this HTTP is more simple than the socket. But okay, so speaking of the HTTP, that will bring my next topic, contact, WebSocket. So WebSocket was the first reference as a TCP connection in the HTML5 around the 2014. So before the HTML5 introduced, the connection from the client to the site, a server usually use the HTTP. So, but you may well make curious why we have to introduce the WebSocket. So that's the common. Use this question, we will go to simply introduce a little bit about the HTTP. So the full name of HTTP is a hypertext transfer protocol. It's a protocol, and it is an application protocol for distribute or collaborative and hypermedia information system. So this HTTP connection defined functions as a request and a response protocol in the client-server computing model. Basically, that means just the client side send a request to the server. After the server got the request and the response and the searching or retrieve the data from the database and respond this request to the server back. So this is like a really simple but the old-fashioned way. However, there are some problem there. For example, the first, the polling. The polling provided from the HTTP is kind of like just as mentioned. The client side first send to the request to the server. And after the server got the data from the database, they respond back, and this connection is closed. This is one connection between the server and the client. It's simple and it works fine, but think about this question. What if the client keeps sending the request, but the server doesn't respond in time? Hypothetically, if you send the server like several different kind of requests to the server, however, the server cannot just respond to you as soon as possible. You're gonna wait a little time. But in this situation, this doesn't work really effectively. So later, developers adjust modify the HTTP or will provide a long polling. Long polling compared to the polling, the long polling has better functionality to provide this service. Like client can send a request as usual, and the server responds, and then the connection closed. And the client send another request. However, this time the server cannot handle this request immediately. So the server gonna hold this request for a while, and until the data is ready, or network is timeout. Then after the find the right data and then just respond back and finish this connection. This just like the one mechanism applied from the HTTP new version to provide this functionality. However, let's think about another question. What if the client doesn't send the request enough, but the server keeps updating very fast? Like hypothetically, we're in a chat room. You are chatting with someone else. Well, you probably type a little slower because you're a foreigner, not really familiar with this language. But your friends keep typing. You have no idea what they are talking about because you haven't sent any request to the server. So in this scenario, how you can just handle this problem? That's why we introduced the WebSocket. So basically, WebSocket is a computer communication protocol. It's providing a full duplex communication channels over a single TCP connection. So finally, the WebSocket introduced the TCP, this concept, into our web application. So how does it work? Okay, so like, for example, like right now, our client send a request to a server, like this code, and the first two lines still is a typical HTTP request header. First, you're gonna send to the header, tell the server that I'm going to connect to you, and next is totally different. It's a totally different concept than before. This is the this is a new method. It's called a WebSocket, right? So right now here, the client side tell the server that I'm using a WebSocket to connect to. Please provide the same service to me, and then send the key and the particle, the version, and to the server. And after the server receive this request, and notice that this time the client side is using the WebSocket to connect it. So it's gonna respond it. So here is the one last time the HTTP works. So after this connection built it, the rest of the connection will be based on the TCP connection. So basically, we use this picture to showing how generally the client side and the server side how to work with each other. So the first time the client side like send a handshake to the server and tell them I'm gonna use WebSocket to connect to you. And after the server receive this request and responded and build the connection, the rest will be like rest of bi-directional message will be run on the TCP connection until the one of the side just close to the channel, and then the whole connection just closed or disconnected. So even even the name of the WebSocket, you probably think, okay, so this socket only run on the different web, but actually it can be also used on the different application or server application. Right now, currently, people already developed the WebSocket based on C language called the lib WebSocket, and someone developed the WebSocket based on the Node.js called the Socket.io. We already use this in our project, and then someone also there's based on the Python of the WebSocket for Python, and the C++ already implemented. So right now, let's think about what's the different, or what's the similar, or what's the different about the WebSocket versus the traditional HTTP connection. So according to what I introduced you guys before, you all probably already understand that the WebSocket actually only connects a little bit HTTP, because the first time we have the client side build the connection with the server side, we use the HTTP handshake. After the connection build it, the rest will totally different with the HTTP connection. So let's talk about the WebSocket's advantage and disadvantage. First, though, as we can see, the full duplex communication is so unique and fresh idea presented in the WebSocket, because this time we actually don't need to wait or like broke the traditional mode, like send a request, respond. This is just a totally new idea that WebSocket delivers communication between the client and the service in both direction and stimulations. Oh, you imagine the developer have to, before before the developer probably gonna have to find a full way to use technology called a POL and long POL, but now we don't need that at all. We just use HTTP connect, build a connection, and you can just retrieve the real-time data or message. And the next advantage of course is increase the communication efficiency. Traditionally web application requires the user to establish a connection to a back server using the really heavy HTTP server. But for the two WebSocket frame, you just use a TCP connection and connect to each other. It will be very effective. And also, this WebSocket is really friendly to the users or developers. Before, you probably had to create the socket instance and find and keep the programming for the rest in the Java or C#. And you probably sometimes you have a difficulty connecting these clients at a real-time data. But now, after the WebSocket introduced, the people can easily developer can easily use the API. Like when we were doing our project, mini project using the socket IO, we only can just using the API directly. It's really easy and simple. However, also the WebSocket has its own disadvantage. As we said, basically once the connection built it, basically the client side and the server side they stay connection until one of them are just close. That means hypothetically, that means your phone still always gonna connect with the server. That's gonna cost you a lot of data. So money, it's about money. And also you see before we talked about the header, compared with the traditional HTTP header, WebSocket header is a little bit bigger. And of course, because the server side, the client side are always connect to the server side, the resource gonna consume a lot than the traditional way. Okay, so the final comparison is between the socket to a WebSocket. So basically, the socket is not a particle; it's just like a abstractical layer on OSI model. And it's more like API. But the WebSocket is a particle. It's a complete particle. You can just use it on the different on the application layer. And also, the socket is packing the TCP or IP or UDP, different transportation particles. The WebSocket is more like extension HTTP and based on the TCP. And the socket can be used in a different interface function, like we create it, we close it in Java. But the WebSocket, you use the HTTP handshake to communicate with the server side, then build the connection. So to build a socket, basically first we have to build a TCP connection first. Then we use the IP to identify the server and find the server. Then later, when we can just creating the socket instance in our program. For the WebSocket, it's much more simpler. It's just sending the HTTP header to the handshake, and then just build a TCP channel, and you can use it directly. So from this table, you already can tell the WebSocket is more convenient to the users or developers. However, the socket is more flexible. You can just use in a different scenario and situation. So that's all my presentation. Thank you, guys.
Thank you, Kai. That was interesting. All right. I think we're done with all presentations, and it was the last time, the last event. I hope you all, or some of you, got excited about this opportunity and actually learned something.
Yeah.
And that's pretty much it. So, anybody have any questions?
I don't have any questions.
All right. So you should be able to observe the way how others graded your presentation performance on the report side of the Fair Grader. I don't think that many students participated in grading. At least this is the conclusion that I made by observing real-time grading performance. But anyway, you will have at least my feedback, at least my grading for the presentation, and that's it. All right, if you have no questions, we stop today and we're good to go to the end of semester.
Thank you, Dr.
All right, have a good day, guys.